third lab assignment for Dr. Greco's Physics 1 class. And here's the video I used to observe constant velocity. And it's just me doing the moonwalk in my dorm hall, trying to be cool. Okay, so I put this video on a program called Tracker, and I clipped the video to a smaller section just to get a more accurate constant velocity. So I put it here, and when I press play, you'll see that for each frame of the video I plotted my center of my mass. And you can see it plotting over right here on the side. And within these 4 seconds, I moved about 3 meters. And that gave me about a constant velocity of 0.75 meters per second in this direction. And here are my data points right here. And then before I plotted these points on Excel, I made a prediction using Python. Here's all the nasty code right here, and when I run this code, you'll see a ball that moves at a constant velocity of 3.75 in the positive direction, and this is the graph that comes from it. See, 4 seconds, 3 meters. And when I ran this code, the data points for this graph right here ended up in this Python test CVS. And so, with both the data points, my actual data points, this from Tracker, and my prediction data points, this one from Python, I graphed both. The red is my predicted data points, and the blue is my actual data points. And as you can see, my actual data points is relative, well, my predicted data points is pretty close to my actual data points, making my predicted data accurate. Okay. And so to finish this assignment, I need to answer 3 questions. 2 questions, I mean. What if, when you analyzed your video data in Tracker, you made a choice of origin for your coordinate system? Discuss briefly how your results would change and how they would remain the same if you made a different choice of origin. So here are my graphs. I change the choice of origin. Let's say I started at 1 meter. It would still have the same constant velocity. So you would see this same graph at 1 with the same slope. If I put it at negative 0.5 meters, it would start right here, have the same slope, and just go up this way. Basically, if I change the position, the only thing that would change would be my constant velocity. I mean, not only thing that would change would be my position. My constant velocity stays the same. Sorry for that. Second question. What does it mean? Your observations can be predicted well by your computational model when you set the net force equal to 0 in your model. Is it possible for you to say how many pushes and pulls are added together to give 0 net force in the case that you observe? Discuss briefly. I don't know if it's completely possible to say, but I could say as much as I can on what forces are acting on me. Air resistance is probably acting on me, but very minimal, because I'm moving at such a slow speed that it's negligible. There's gravity acting on me, but that's canceled by the ground with an upward force. And then there's also friction acting on me, but it's canceled by my feet pushing on the ground to propel me forward. And those are the forces that I thought up of. Well, thank you for watching my video.